And it's 8 live on eTV. You're welcome to tonight's edition of Fact Sheet. Here, it's always about the facts and nothing but the fact. Tonight, we are talking about the state of affairs of our country when it comes to health and COVID-19, the effort to secure vaccines, the absence of vaccines, the statement which came from Noguchi about how they have tested several people and how widespread the Delta variant can be found in our communities. The efforts and recommendations they preferred for government to take, the steps they believe as Ghanaians we must be taking. And the warning that people who have already been vaccinated by the Ghana Health Service are being reinfected with the Delta variant of the COVID-19. What it is, how it's transmitted, how it impacts on your health. The situation we find ourselves in as a nation, the steps we ought to take to mitigate the spread of COVID-19. His Excellency the President had his dialogue, the usual one, the conversation with Ghanaians, and he enumerated a couple of steps that he believes we ought to take to mitigate the spread of the disease. Those measures from the perspective of you, the Ghanaian, and our medical doctors who have been sounding the alarm, the warning about how fast the Delta variant is spreading. Would it suffice when it comes to the control of the Delta variant in our communities? Tonight, that's what we are talking about, understanding how the Delta variant spreads, understanding the risks that, we all are exposed to and how we can bring it down. With the wearing of the nose masks, social distancing, and the washing of our hands, stop the spread of the Delta variant. My name is Samuel Ishen, and I'm happy to welcome you to the conversation tonight on eTV and live on Facebook as well. We'll take a short break. When we come back, my guests are here with me, and they would help us understand what the Delta variant is all about. Stay with us. And welcome back to Fact Sheets live on eTV, live on Facebook, Twitter, and Instagram as well. We encourage you to join the conversation and share your thoughts with us live on the show tonight as we discuss issues to do with COVID-19. As earlier, when we started the conversation, I told you that I'd be having guests join me in the studio. I have one in the studio with me, and then the other would be joining us via Zoom tonight. I have Dr. Peter Kojo Kwashi in the studio with me. He's a senior research fellow with WACBIP, and Dr. Kojo Asamoah Kusi. He's also a senior research fellow, Immunology Department, Noguchi Memorial Institute for Medical Research, University of Ghana. They're joining us for us to have an understanding of what the Delta variant is all about and the steps we ought to take to mitigate its spread. Gentlemen, you're welcome to the show tonight.
Good evening.
All right, so I'll start with you, Peter, for a general comment on the effort at, combating COVID-19, the, Delta variant, we heard about it. Yes. It was in India, and how it slipped into our country, and today it's virtually ravaging all of us.
Yes. So the Delta variant is something that we've been sort of dreading its inevitable entry into the country since it took over India and then the UK and then all around the world. So it's something that we've been tracking and hoping that it wouldn't enter, while at the same time knowing that because it's a respiratory virus, it's sort of inevitable that eventually it'll find its way into the country. So right now it's here. It looks like it's been here since May, and it's starting to, and it's quite entrenched now.
You say it looks like it's been here since May?
Likely.
How do you arrive at that conclusion? What makes you think so?
Just based on when the cases start to rise. So if you look at when the cases start to rise, and currently all the cases are linked to all the symptomatic cases tend to be Delta. So if you look at the time when it started to rise, you can guess when it came in.
All right. Now, let me ask Dr. Kusi for an initial comment as well as to the effort to combat COVID-19. Doc, have we done well, or have we done enough to bring down this disease or to control it?
To your viewers, I think we started very well. In fact, globally, we were touted as one of maybe the top 5 countries that was able to control this thing very well with a combination of strategies, and especially with the presidential addresses came in for commendation as to relaying information in a timely manner to the populace. And also with the graduated measures that were put in place to stem the tide. But I think somewhere along the way, we sort of relaxed and slipped into a state of denial, thinking that this was going to be over very soon. And I think that is very clear in the president's last address on Sunday, when he said at the beginning that he expected that the next time he addressed the nation, he was going to tell us that the disease was over. So I think we all sort of, not all of us, but a lot of people sort of got into the thinking that this was almost over. And so we let our guard down, and we are now back to the situation. So as at now, we are not really handling this well. In fact, since the address on Sunday, I expected to see some change in terms of the directives that the president gave. But you still walk through town, and it's like every other day. People are just not wearing the masks, and business goes on as usual.
So how do you feel as scientists when you witness day by day the non-compliance by citizens, and how dangerous this disease is?
And let me tell you the truth. Sometimes you are even put under pressure in terms of when you have to go somewhere and you are the only one wearing it. It's almost like you rather do not know what is going on. It's almost like the disease is gone and you are still wearing your mask. So it is very worrying, because when we look at the data coming from other countries, or even the pictures coming from other countries, and the devastation that this disease has caused, and we see how we are handling it here, it is very troubling, because this killed a lot of people in Europe, in North America, in South America. We were lucky the first, second waves wasn't that serious. I mean, relatively, because in our terms, it might be serious. I must say, I was having a chat with a collaborator in the US on Sunday, when she asked me about our case counts now. And when I told her the numbers, and 821 deaths, her question was, is that for the whole time that COVID has been around, or just recently? And I'm like, that's all we have. Now, although that might be an underrepresentation because of limited testing, it paled in comparison with what she knows as the figures in the US. So we need to be very careful, and it is very worrying, because if this gets out of hand, we might not be second time lucky. The first time we were lucky because the number of deaths, the number of cases were much, much lower compared to the other parts of the world. So if we let our guard down, and this Delta variant is as we have seen it in other places, then we are in for a challenge. And if we keep going on the trajectory that we are on now, we are heading for trouble.
Yeah, because he uses the word luck in his submission. I thought, you guys are scientists, and so you deal with data, facts, and all. But he keeps using the word luck. Is it really luck that has gotten us where we are, or it's as a result of some, research work we have done as a nation, or something that we are doing right that's making the disease not rise to the numbers and the death tolls going up?
Well, I mean, we can talk about some research that some findings that are starting to come out as to why we have been lucky. I would usually I like to use the word fortunate
Mm.
because I don't particularly like luck. But I don't, and none of us believe that it's because of something that we are doing as a population. That is why we have just been very fortunate by virtue of where we are, likely by virtue of the sort of pathogens that we have been exposed to as a population. And really, even taking all that into consideration, it's been very baffling for us because we see these variants, even when the Alpha variant was here in January, February, and the ICUs were full, people were dying, but on the whole, most people were recovering. Even those who were very seriously sick were recovering. And it was very surprising compared to what you see outside Ghana. So I will agree that we have been very, very fortunate.
Has some research work been done, I mean, to try to ascertain what is doing the trick for us, even if it's lack of fortune? Is there some research work that's going on?
So we are doing some work right now.
Mm.
And you know, early on in the outbreak, early on in the pandemic, what was clear was that some of the people who were dying from what we call cytokine storm, which is basically, to put it in simplest terms, when your immune system overreacts, then it ends up killing you.
Mm.
And one of the hypotheses that we have is that because in Ghana, for instance, we are used to constantly getting malaria. So you have what we term an attenuated response. So our immune system doesn't overreact because we are constantly being infected with things. So we have some preliminary data which is coming out to show that at least in the samples that we've looked at, we don't seem to see a lot of that cytokine storm that is being reported elsewhere.
Mm.
And some of these cytokines which are supposed to be elevated are actually not elevated, even in the severe cases. So we're starting to get some data right now. It's still early days yet, but at least we're starting to get some understanding of why we are not as affected as elsewhere.
Well, if the research you are doing per exposure to certain diseases and all, systems have been able to build some level of immunity and have gotten adjusted to some of these things, then indeed we have no cause to be worried, should we? Let me ask Kusi about that one. Should we be worried? Should we be concerned if, since last year, the number of cases we have recorded, the number of death tolls we have recorded, ain't that significant? Obviously, something must be right somewhere within our systems, and so we should not be worried.
Okay, the point is that, and I use the word luck because as of now, there is no concrete data that explains why. There's been a lot of theories that have been propounded to explain this. What Peter talks about the cytokine storm and the fact that because of our high exposure burden to infections, we are able to handle those cytokines better than people who live in much cleaner environments. And that is a theory that has been well proven, for example, in a disease like asthma, where you have persons who live in very clean environments being very susceptible to asthmas, while those who live in slightly dirtier environments or dirty environments are more resistant to it because their immune systems are constantly being challenged, and therefore they are able to handle these very well. Other things that have been used to explain this is, for example, the young age, average age in Africa is much lower. Okay, and there are a number of other things that have been used to explain this. But of course, none of them is really conclusive. There are also bits that come from vaccines that are being used, especially when you talk about children. But all of these are, as I said, just theories. when it comes to our being lucky, the reason why we cannot go on riding on that luck is that we are seeing the evolution of different variants now. We never know when a variant that we are most susceptible to will emerge. So we've started with variants that we have been shown to be more resistant to, and therefore it didn't really get to us like it did other countries. But when we have the emergence of a variant that we are not that resistant to, then what happens? We at that point, it's not at that point that we are now going to force people to do or to protect themselves. We need to already get into that habit so that whatever comes out there, you'll be prepared against it. Because there's every possibility that we will come up with variants that probably could cause more damage to us. A case that I can easily remember is for HIV/AIDS, where in somewhere in East Africa, I think in Kenya or Uganda, there was this tribe that was said to have some genetic makeup that made them a bit more resistant to HIV than the average population. I think, I don't know for sure, but I think that sort of got to them. Some of them didn't really protect themselves from this, and subsequently a lot of them succumbed to the disease. So while these organisms are changing, they are changing with the intent of surviving. And so there is every possibility that we are likely to have a variant that we will be very susceptible to. So if we don't learn to defend ourselves now by doing everything possible, when that time comes, it might be too late to really get anything done the right way.
All right, now let's come to the Science 101. We have been talking about a virus. But we know there's bacteria and all. Why do we classify any of these, for want of a better word, germs or diseases as a virus and others as bacteria? What's the difference? What makes the COVID-19 a virus and not a bacteria?
So a virus is what we call a living particle. Mm. You can't really call it a living thing because the virus needs to be inside your cell. It needs to be inside the body before it can reproduce. Mm. So you know there's some qualities of life, and one of the qualities of life is that you have to have the ability to reproduce yourself. So a virus outside the body cannot reproduce. So that's why you can't call it a living organism. Mm. It can, once it's in, it infects you, then it takes over your system to reproduce itself. A bacteria has the ability to reproduce and to replicate.
Outside of the body?
Outside of the body.
Okay.
So that's a living organism. So it's just a classification thing.
All right, so now let's try to understand the variant word you keep using.
Right.
What's that variant? Because we had the alpha, and then now we have delta, and I don't know what next is going to come.
So basically, when, you know, before we heard the term variant, we know the term mutant. Mm-hmm. So if the genomic material, there's any changes in the genomic material, what we say is that that's a mutation. Now the variant is the result of the mutation. If the mutation results in a change in the virus or the change in the way that the virus behaves, then it's a variant. Now all the time there's many variants which are being made. But it's only the ones which we see a perceptible change, or the ones which have a competitive advantage, that will rise up within the number of infected people, and that's what we will notice, and that's when it will be assigned that this is a variant and it's spreading, because if it's spreading, that means it has a competitive advantage over the one that was there before. Mm. So right now we have Delta, and we know that Delta has, it replicates faster and it's more transmissible than the previous variants.
All right. Now, let me ask about some of these terminologies before finally we look at the Delta variant itself and the dangers it poses to us. Now, I'm trying to understand what you mean when you say viral load. In the statement that Noguchi released, there was a lot of repetitive usage of the word viral load and the fact that it's high and all.
Yeah.
So, Dr. Kusi, I'm trying to understand, what do you mean when you say viral load being high?
Very much. So, just like you would have, let's take human beings, okay? While we are on Earth, as you give birth to one child, to two children, you are multiplying yourself, right? So, the viral load, we are talking about how many viral particles are in your system at any point in time. Okay, so the virus also has the capacity to multiply, like Peter said, using your cells to make more of itself. So the viral load has to do with how many viral particles you have in your system at any point in time. So what was in the release was that the cases we are seeing now have many more viral particles in persons who test positive than used to be.
All right, and then the final one before we start, looking at the variant itself, the Delta variant itself, there is another terminology that, so far since we started having a conversation about viruses, and especially the COVID-19, the virus of concern. What does it mean when, you speak of a virus of concern?
Okay, so those are classifications that the WHO makes. So as the variants come up, as the different types of the viruses emerge through their normal activities, the WHO and in fact many established bodies track how these viruses spread. Okay, and then also whether the disease they cause is more severe than some other variants. So when they begin tracking these, initially these are labeled as variants of interest. It means watch out for this one. It might be something that you would want to protect yourself against at a later time because of the way it is behaving. So they are first labeled as variants of interest because they are beginning to show characteristics that either predispose them to being more transmissible. In other words, they can be easily passed on from one person to another, or to cause more disease. So when they observe for some time and they now begin to see real signs that indeed these two features are showing, then it moves from the variant of interest to become a variant of concern, one that you should now try to focus on because it is going to cause havoc if you allow it to just run amok.
So let me come to the studio and ask. What is the Delta variant that everybody is afraid
of? Meaning, what is the features of it?
Yes.
So it has some mutations, which one allows it to replicate faster in the cells, and it also has similar mutations to the alpha variant, which allows it to bind to the cell receptor tighter. So then it can basically be more infectious, and those two features are what allows it to be more transmissible and to spread faster. One, when it infects you, within a short time, it can replicate. And like Asama Kusi said, you have more particles within your respiratory system faster. And so now you are more infectious, you are going to spread it faster because of the higher replication thing. And if you are spreading it, because it now has a higher higher affinity, or it binds tighter to the receptor, then the person who is next to you is more likely to become infected. So those are the two things that make it.
So let's say in the studio, having a conversation, we are both unprotected, and then I either contracted from you or you contracted from me. Where would the virus be targeting the moment it enters into your system?
So when it enters into your system, what we call the respiratory interface, right? You have epithelial cells. There are some cells which line there, and they have the receptor. So it's not really targeting, it's just random. But now, because it has a higher affinity, whereas maybe you would need about 100 particles to establish an infection, now you only need maybe 2 or 3 particles to establish an infection, because usually it's a game of numbers. You can be exposed, but if there's not enough particles, you will never be infected. In this case, the infected person is producing so many viral particles that, for instance, early on in the pandemic, if you're infected, and let's say you're a household of 5, not everybody is going to get it, maybe 2 or 3 people. During the second wave, if, let's say you're a household of 5 and 2 people will get it, during the second wave, let's say 3 people will get it. Now with Delta, if you're infected, likely everyone in your house will get it, just because of the sheer number of particles that you are going to be producing.
I don't know where we stand now, because when we are talking about these viruses, but I remember one of the controversial issues that popped up was whether it was an airborne disease or not. As we speak now, is the Delta variant an airborne one?
So, okay.
All right, Dr. Kusi.
There is no indication, no concrete indication that it is airborne. It is still a droplet infection. So the difference is that for an airborne infection, you expect that when, for example, you sneeze and the viral particles come out, they would linger in the air for maybe some hours. And that diseases that are spread like that can be very dangerous, because all you need to do is to probably walk in a space where someone who sneezed has walked in, and you can catch it because it suspends in the air for quite a long time. What is known with COVID is that it is mostly in the droplets. And you see these droplets, especially around a time when we had this craze of wearing face mask, face shields. Okay, when someone wears a face shield and talks a lot, you can see the droplets on the inside of the shield. Okay, so these droplets, as you sneeze, as you cough, as you are talking, and they come out, contain the viral particles. They can travel a short distance in the air, but the particles are quite heavy, so will settle very quickly. And that is why we talk about social distancing of about 2 meters, because it is known that the viruses cannot jump or cannot move in the air over that distance. So most of the time, these particles will come out of someone who is infected as part of the droplets, and then they settle on surfaces. And that is why there is also the hand washing prevention protocol, because if you touch any of these, you brought it onto your hands. And if you touch any exposed part, your eyes, your nose, your mouth, you are getting the virus into your system. Okay, so as of now, there is no classification of this yet as an airborne disease. It's just a droplet infection.
To the signs and symptoms you should be experiencing when you contract the Delta variant as compared to the Alpha one. What are the differences?
Basically, there is not much difference between the in terms of the symptoms that you feel. I mean, this is the fever, is the weakness, and it's very varied. I mean, not everybody experiences all the symptoms at the same time. The difference is that with the Delta, and looking at the explanation that Dr. Kwashi gave, the Delta, your viral load is so high that you get sick probably faster, because viruses are one group of organisms that most of the time, it is your immune system that can actually kill them. The drugs are not effective in terms of killing the viruses. They will just slow them down. They will stop them from multiplying further. but your immune system is basically what would clear these viruses most of the time. Unless, of course, if you have a drug that is supposed to trigger your immune system to do that. But if you are taking a drug that is targeting the virus, it is basically stopping the virus from further multiplying, making more of itself. And then whatever little is there and is sitting around in your body is gradually cleared by your immune system. So when the viral load is very high, when you have a lot of viral particles in your system, it definitely would mean that it would take a longer time for your immune system to clear it than if you had a smaller viral load. And it is that results in the more severe disease, because it's almost like the viruses overwhelm your system because they are much more than your system can cope with at any time. So they overwhelm your system. And so if in terms of disease, you might get sick faster than compared to the alpha or maybe even the original Wuhan strain.
Why are people not getting sick more? Why are we not recording cases of people, if indeed we are having these numbers going up as a result of the Delta variant and it has the capacity to reproduce quickly? Why are we recording cases where people are in very dire situations where, our ICUs would by now be, overwhelmed?
As far as I know, people are getting sick more. And the samples that we've sequenced, which have been Delta, are usually very sick people and seriously sick individuals. So I just want to get back to something that Dr. Kusi mentioned early on. You see, early on in the pandemic, I mentioned cytokine storm, and that's how people were dying. And what it looked like was an immune system, whether your immune system could cope or it couldn't cope. And then we saw a shift where from it being about your immune system, it became about the virus, right? That happened when we had the alpha variant, and now it's the Delta variant. So it's the features of the virus that are driving the severity. And I don't think it is that different here in Ghana. More so than the previous waves, it looks like it's affecting people severely. But of course, there's always a time lag between when these cases start to appear and when we start to hear of it. But as far as I know, it's at least in Greater Accra region and Kumasi, it is affecting people severely. And then there are some people who may have already gotten at least one dose of the vaccine, and then in those cases, they may not be exhibiting symptoms or severe symptoms, but they still have a high viral load.
Forgive my appreciation of the science if my logic is not too logical. Now, if the alpha variant, let's say, was replicating at a speed of, let's say, 5 alpha variants within 5 minutes. And then the Delta one is able to replicate, let's say, 10 times within the same 5 minutes. Chances of people being asymptomatic with the alpha variant would obviously be very high as compared to that of the Delta variant, if my logic is correct.
Yes.
Why do we still have asymptomatic cases, a lot of them? People are walking about having the Delta variant, and yet they are okay.
I think that's where it's that's where the hypothesis about whether it's our immune system or some aspects of our blood composition comes in, and that's where the evidence is still being gathered about that. But what it looks like is that at least in the cases where you have confirmed Delta, usually there's symptoms. Unlike before, in the cases where I've seen where, okay, this person has Delta, we've sequenced it, it's mostly symptomatic cases.
Wow. So, Dr. Kusi, let me come back to you and ask another question, which has to do with, the Delta and how we are handling it. Could there be a possibility majority of the population have built immunity to the alpha variant, and so That's how come our numbers are not as high as we saw in India.
Before I come to this, just 30 seconds to speak to the last question you asked. So I think according to the Ghana Medical Association, our ICUs are halfway or probably over halfway full as we speak now. So the cases between, let's say, March and now, and probably after the first wave where we went from having all the hospital beds mostly empty, is no more. The beds are filling up. And if we look at the Delta variant and what it did in India, it actually even crippled vaccine manufacture in India. So it is not for anything that we are making this point. And once again, it comes back to the fact that there is something here with us that makes it not look that serious as it is, because in the US, in Europe, in other places, the Delta strain is really causing a lot of havoc. As of now, I think it's in close to 100 countries that have this Delta strain. In the US, you have this making up almost a little over 90% of new cases that they are sequencing. In the UK, the numbers were, I think, 3 or 4 days ago, over 83%. So the Delta strain is really taking roots and more or less pushing out the other ones, because it looks like your immunity to the other ones is quite solid, maybe through vaccination. But that clearly shows that, and especially for people who have not been vaccinated, even if you've been infected with the other variants, the immunity you have built may not be as strong or as potent against the Delta as it should be. In fact, the manufacturers of these vaccines have themselves done some in vitro testing that shows that the antibodies that you make against the vaccines are not as effective against the Delta as they are against the other variants. And in fact, have gone on to recommend that they think that probably booster shots will be necessary, even for those who are fully vaccinated. So yes, immunity could play a part in terms of what you've already been exposed to. But I think that makes up a very small portion of the picture as we are seeing it. The same mechanisms that protected us from the first, the second wave would still be at play, definitely. But I think the Delta has shown or has proven itself to be one that defies even the vaccines, the best vaccines that we have now. And so, yeah, we cannot completely rely on what we have now and not protect ourselves.
Now, since you're with Noguchi, let me ask this. They made reference to the fact that they had cases where people who had tested positive for the COVID-19, the Delta variant, had taken the full shot of the vaccines. Now, how is that possible?
That is expected. None of the vaccines is fully efficacious. So there was always the chance that even in the fully vaccinated persons, you could get infected, not just with the Delta, even with the other ones. So that is not surprising. And that is why there was also advice to go with it, that even when you are fully vaccinated, it was still important to keep your mask on. Now, the risk with persons who have been vaccinated being a focal point for transmission is that if you feel you are vaccinated and you take your masks off, the vaccines were designed and efficacy points measured against symptomatic disease, you actually coming down with disease symptoms, not against infection. So the vaccines do not protect you from getting infected, just that when you are infected, it's able, the immune system you have built based on the vaccine is able to reduce the viral load such that you will not end up in hospital or get sick or feel sick. But there was never a communication that the vaccine stops you from getting infected. So that really is not surprising. It's just that in those who are vaccinated, maybe what you are likely to see are viral variants that are very different from what the vaccine is based on, because the vaccine is based on some variant of the virus. Okay, so in people who are vaccinated, at best, what you would see is they getting infected and maybe showing quite a good, I should say, quite a high viral load with variants that are very different from what the vaccine was based on.
All right. So, again, my ordinary man's logic. I'm hoping that it sounds logical. So, there are people in the country who have taken just the first shot. Now, these individuals get infected along the way by this Delta variant. There's a high possibility a battle would ensue because their body systems would try to fight them off,
right,
as they have been given some booster.
Right.
Now, in the event that that battle goes on, the Delta variant now, in trying to overpower this, what is in the person's system or the boost in the person's system, may have the possibility of again replicating into something much stronger than the original variant, which is the Delta one, and then we may see a much stronger one. Is that scenario a possibility?
That scenario is a possibility whether you're vaccinated or not. Actually, it's a stronger possibility in the unvaccinated person. I mean, it's a strong possibility both in the, it's more in the unvaccinated person, because the emergence of variants is faster when you have high level of replication. Now, as long as you have some protective antibodies or some T-cell immunity that will reduce the viral load, then the chance of the emergence of variants will go down. To the point you are making is that if you are already protected against Delta, which none of the vaccines fully do, but assuming you were protected against, let's say, the original strain, and then you are now infected, but you only have partial protection, and you're infected by that strain again, then yes, you can have some immune pressure, but it's more likely that it's in an completely unvaccinated individual who, especially if they have a suppressed immune system, and the virus can linger for a long time in their body and replicate. That's where multiple mutations can come up. And if there's one set of mutations that give it competitive advantage, that's how it spreads. You know.
All right, we will go for a short breather. When we come back, we will try to understand the mechanisms that have to come into play when we are talking about the production of our own vaccines in this country. I've listened to conversations on other international networks where they have made the point that even if the patent rights on some of these vaccines that we are talking about were to be lifted, it would take some of us, the developing nations, some 2 years for us to be fully ready to understand the science behind it and to have the equipment and the structures to produce our own vaccines. So, if we're starting from ground up, are these two doctors who are with me cocksure that possibility would happen the next 2-3 years? We'll be right back. All right, you're welcome back to the conversation. You're live on eTV, live on Facebook as well, Twitter and Instagram. My guests, Dr. Kusi and Dr. Kwashi, and we're talking about the Delta variant, trying to have an appreciable understanding of the virus, COVID-19, and how we should protect ourselves. We have 10 minutes before the show comes to an end. I'll give my guests 2 minutes each to give me an understanding of what goes into, manufacturing your own vaccine, if we were to take the step today, as the president has indicated and has boldly committed to ensure it happens. Look, that pronouncement, how do you feel about it?
Well, I think it's a step in the right direction in terms of It's kind of shameful that as a continent we don't have the capacity to produce our own vaccines. However, there are some countries, first world countries, such as Canada, Australia, that do not have the capacity to produce their own vaccines. And the reasons for this is that there are some logistical challenges that come along with it. There's sourcing raw materials, there's getting the materials to you, and actually building the facilities that you require, the clean, what we call GMP facilities, good manufacturing practices facilities that will allow you to be able to produce these vaccines. And then you come to the intellectual property. And those, once that knowledge is transferred, I think those can be learned and transferred fairly, not easily, but it's less of a problem once you have that intellectual property. But you have to, the logistical challenges are not trivial. And already for us in research, we have severe logistical challenges in just getting our reagents and getting our things in there. So it's something that has to be looked at. It's, you have to have the facility built, you have to have the logistics, you have to have the intellectual property, or we can go the route of looking for vaccine targets, you know, doing it from basic science. And I think really, as much as we would like to say that this is going to benefit COVID-19 response, it's going to take some time. So what this would build would be capacity for that future outbreak, that future pandemic. I think it will be very challenging to be able to get off the ground, build all this infrastructure, get all these logistics sorted out, get all the IP issues sorted out, and actually, once you've done all that, that's all paperwork. Then you actually have to do the work, and you have to produce the vaccines. You have to do clinical trials to make sure that your vaccines meet equivalence with the established ones. So it's going to take some time, but I think it is a step that we need to take.
But if for instance, the Pfizers and the Modernas and co were to waive their patent rights, are we in a capacity to produce locally?
To produce, like I said, you have to build the infrastructure.
So even that, it's looking into the near future, not now.
That will make it closer. You know, you have to build RNA vaccines. Dr. Kwesi may want to weigh in on this. I mean, it will be closer, but it's not going to be like 3 months down the line or 6 months down the line. You know, I think it will be at least a year to 2 years before, because we don't have a facility right now in the country where we can produce that.
Dr. Kwesi, final question to you. If we say we are going to produce, how long should we give ourselves?
I think it depends on the investment that is put in. Like has been said, there is an infrastructure deficit. There is a lot that needs to be on the ground. And I'm happy that the president's announcement even included, you know, resourcing the FDA, because that is another crucial part of vaccine development, to have a strong regulatory system in place to be able to check the production process and the testing process. I think that we have bits and pieces of capacity on the ground, but it's very sparsely located, and we need to consolidate and build the right partnerships. Because as at now, you know, I hear a lot of Ghanaians say, "Oh, why are our scientists not making vaccines for us?" But it takes a lot to make vaccines. It's not a one-man job, and I must typically say that vaccine production or development begins with basic research, and then you move whatever good products you get from the lab into a production environment. And at that point, it's become so costly that you as a basic scientist sometimes do not have a hang over it. Okay, so it calls for partnership between those who are doing the basic research to discover what would be a good vaccine, and then having the financial muscle, and that's where the big pharma companies come in to move such a product forward into GMP production. And then later on, when it comes to now testing these vaccines, especially at a clinical stage, then you have the basic scientists probably coming back in to help with that arm. So it requires that partnership and a lot of investment and a consistent flow of resources to be able to get this done. I can say that throughout Africa, there are about 5 or 6 countries that are into any form of vaccine production, whether right from scratch or at the tail end where they are just bottling it. Africa is said to produce less than 1% of the vaccine that is used globally. But we are a very huge consumer because most of the things that there are vaccines for are in Africa anyway. So it's a call in the right direction, and we should be able to see this as a national call and to be able to put all that we have together to get this going. And I must say that it is not going to be something in a very few years, 1 or 2 years. And also the vaccine institute that the president talked about is not just focused on COVID as we see it, but being able to put in place a structure for the long term and to be able to make some of the vaccines that we need for other diseases as well.
All right. Dr. Kwasi, I'm grateful you join us tonight on the show. Dr. Kwasi, I'm grateful you join us tonight on the show.
Thanks.
Our time is fast spent, and so we'll end it here, but I'm sure we'll have time to also deliberate further on some of these issues, especially when it comes to the vaccine production. But until then, once again, I thank you. My name is Samuel Ishen. I leave you in the capable hands of Mercy B and the team. Go Vibes is up next.